So, MP Isra Debalan, Department of Civil Engineering, Rogini College of Engineering and Technology. Name of the subject Strength of Materials. Subject code CE3491. Regulation 2021. The today topic principal plane and principal stresses. The plane which have no shear stress are known as principal plane. Hence, principal plane are the planes of zero shear stress. These planes carry only normal stresses. The normal stresses acting on a principal plane are known as principal stresses. Methods of determining the stresses on oblique section. The stresses on oblique section are determined by the following methods: analytical method and a graphical method. So, followed that the problem at a point within a body subjected to two mutually perpendicular direction, the stresses are 80 Newton per mm square tensile and 40 Newton per mm square tensile. Each of the above stresses is accompanied by a shear stress of 60 Newton per mm square. Full stop. Determine the normal stress, shear stress and resultant stress on an oblique plane inclined at an angle of 45 degree with the axis of minor tensile stress. Given data, the major principal stress sigma 1 is equal to 80 Newton per mm square and minor principal stress sigma 2 is equal to 40 Newton per mm square. The shear stress dou is equal to 60 Newton per mm square and angle of oblique plane with the axis of minor principal stress theta is equal to 45 degree. To find the normal stress and tangential stress and resultant stresses. First to find out the normal stress. The normal stress sigma n is equal to formula sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 cos 2 theta plus r sin 2 theta. So substitute the r value, all value. So sigma 1 is equal to 80 and sigma 2 is equal to 40. Theta value 45 degree, r value 60. That is the shear stress. So answer is 120 Newton per mm square. And next tangent shear stress. So tangent shear stress sigma t is equal to formula sigma 1 minus sigma 2 divided by 2 sin 2 theta minus r cos 2 theta. That is value of 80 minus 40 divided by 2 sin 2 into 45 minus 60 cos 2 into 45. So answer is 20 Newton per mm square. Then next finally resultant stress. So resultant stress, the resultant stress on the section FC will be given as sigma t is equal to sigma n square plus sigma t square. Therefore root of sigma n square plus sigma t square value substitute the root of 120 the whole square plus 20 the whole square. So resultant stress sigma r is equal to final answer 121.65 Newton per mm square. Then another one problem. A rectangular block of material is subjected to a tensile stress of 110 Newton per mm square on one plane and a tensile stress of 47 Newton per mm square on the plane right angles on the former. Each of the above stresses is accompanied by a shear stress of 63 Newton by mm square, and that associated with the former tensile stress tends to rotate the block anticlockwise. Find the direction and magnitude of each of the principal stresses and magnitude of the greatest shear stress. Given data, the major principal stress sigma 1 is equal to 110 Newton by mm square and minor principal stress sigma 2 is equal to 47 Newton by mm square and shear stress r is equal to 63 Newton by mm square. So to find the direction and magnitude of each of the principal stress, and the second one the magnitude of greatest shear stress. The direction and magnitude of principal stresses. First major principal stress. Major principal stress formula sigma 1 plus sigma 2 divided by 2 plus root of sigma 1 minus sigma 2 divided by 2 the whole square plus r square. So substitute the all value. So major principal stress answer 148.936 Newton per mm square, and minor principal stress Similarly, formula sigma 1 plus sigma 2 divided by 2 minus root of sigma 1 minus sigma 2 divided by 2 the whole square plus r square. So answer is 0.064 Newton by mm square. Then direction of resultant stress tan 2 pi is equal to 2c divided by sigma 1 minus sigma 2. Therefore 2 into 63 divided by 110 minus 47. Therefore 2 theta is equal to tan inverse 2. So answer is 63 degree 26 minutes. So pi is equal to 31 degree 43 minutes. Therefore magnitude of greatest shear stress sigma maximum is equal to 1 divided by 2 root of sigma 1 minus sigma 2 the whole square plus 4r square. Therefore answer is 70.436 Newton by mm square. Thank you.